Cool. All right. So in this video, we're going to look at the difference between a permutation and a combination. This little bit right here, this is the notation that they'll use a lot of times, like in books or in a calculator. But so the idea is that you have a set of objects. All right. This could be all sorts of things. It could be a set of numbers, or it could be a set of letters. It could be people. And from that group, you have to choose a certain number of them. So it might be, in this case here, I'm going to choose 3 letters. So from 26, so from a group of 26 letters of the alphabet, I want to choose 3 of them. Now, with a permutation, the order in which you put the letters is going to matter. And with a combination, the order won't matter. So if you pick ABC, that's great. Like for a combination, ABC is the same as CAB. But for a permutation, each one of those are different, are going to be different from each other. All right. So with a permutation, the order in which you choose stuff matters. So like if you were, maybe you're making a batting lineup. So for a batting lineup, the order would matter. But if you're just wanting to choose 9 players to put on the field, right? You don't, like, say you just don't care, then you would just be caring about a combination. All right, so let's do this problem here. So we're going to say 26, choose 3. So on the permutation side, the notation for that, for a permutation side, the notation would be 26, 26 NPR 3. Yeah. Let's see. And then on the combination side, okay, for the combination, it'd be the same idea. You would say 26 NCR 3. So from the 26 letters, you're going to select 3 of them. So just kind of get a feel for the problem. Let's say I did ABC. All right, that would be different than ACB, which would be different than, actually, that's all of them that start with the letter A. Yeah, that's, at least for those 3 letters it is. But that would be different than CAB and CBA, which would be different than BCA and BAC. But on the combination side, ABC, this one part, this one combination would cover all 6 of those, right? Now for the permutation side, the next combination that you would want to try, or the next set, might be ABD, which would then in turn give you DAB, DBA, BDA. It grows really quick. But the nice thing is that for every 6 of these that you have over here on the permutation side, that will match exactly 1 on the combination side. So really, we really just need to be able to answer one of these definitively, and then we're going to have the answer for the other. All right, because for every 6 of these on the left, you get 1 on the right. Now the permutations, it may not feel like it, but we have done these already. All right, so we're choosing 3 letters. All right, so we have to put, 3. We have to put a letter in each of these slots, and we're choosing from a set of 26. And we want to know how many different ways we can do that. Well, for this first position, we have 26 options. And for that second position, we have 25 options since we've already chosen 1. And for that third and final position, there are now 24 options to put there. And using that counting rule, when we multiply this together, that's going to give us the number of permutations. All right. Turns out to be there are 15,600 possible orderings of the letters A, or of 3 letters from the full alphabet. All right. There's 15,600 possible three-letter combinations. All right. And by the way, we're assuming that you cannot repeat a letter. If you could repeat a letter, I guess it would be 26 times 26 times 26. All right. So if this is the number of permutations right here, and we want to know the number of combinations, well, we're just going to divide that by 6. All right. And we're dividing it by 6 because remember, every combination over here accounts for 6 of these permutations on the left. So if I divide that by 6, there's going to be 2,600 different combinations of letters. All right. So hopefully that wasn't too bad. We just we started really with this permutation part, and then from that we were able to get the combination part. All right, let's do a different type of example here. All right, so this is a real similar idea. We've got 11 basketball players, and we're wanting to create a group of 5. All right, we want to know how many ways can we choose 5 players from 11. Now, in normal circumstances, I'm pretty sure we would really just be concerned with the combination formula, because when you're putting 5 players out on the court, the order in which you put them out there probably doesn't matter. So we really just need to know this 11 choose 5, but we're going to have to do the permutation side as well. So 11 NPR 5. All right. So remember, on this side, the permutation, the order is going to matter. All right. Permutation. And then on this side, we're going to have our combination. So maybe if we were kind of thinking of, the position where the ball players go, the permutations would matter, right? Because you wouldn't want to put, your biggest guy at point guard, probably, right? So maybe you would want to actually think about what the proper permutation would be. But there's always going to be more permutations than there are combinations, all right? So let's figure out the permutations first. You've got 5 positions to fill, five spots to fill, and you have 11 options for that first position. All right. Now that one's been filled, you have 10, and then 9, and then 8, and 7. So let's see how big this gets. 11 times 10 times 9 times 8 times 7. Yeah, there's quite a few there. 55,440 to be exact. All right. Now on the combination side, we need to figure out what we have to divide by. On that last example, we were dividing by 6, but that's not going to be the case for this one. All right. So to kind of get a feel for it, what I'm going to do is I'm going to make a combination over here. If I had A, B, C, D, E, all right, this would be one combination. And on the left, A, B, C, D, E would be one permutation. But I want to know all the ways that I can rearrange these 5 players right here. So this would be different than B, A, C, D, E. All right, this would be different than C, B, E, A, D. All right. So we want to ask, how many ways can we just take these 5 players and rearrange them? All right, how many different arrangements are there for those 5 players? And we've looked at this question before. This is actually going to be a factorial. So we want to know ... how many different ways are there? All right. This is going to be 5 factorial. And it's really the same thing as asking that same question. It's similar to that one from above. You're wanting to know how many arrangements there are. Well, for this first position, there are 5 options. For the second position, there are 4, 3, 2, 1. And you're wanting to know how many different ways can you arrange them. Well, that's what a factorial is. 5 factorial turns out to be, let's see here, 120. All right, 120. So just for this one combination, A, B, C, D, E, that one combination is covering 120 different permutations, right? So if there are 55,440 permutations total, then we can divide that by 120 to find the number of combinations there will be. Divided by 120, this comes out to 462. So if you don't care about the order in which you put those 5 basketball players out on the floor, if you have 11 and you're choosing 5, there's 462 ways to do that. Cool.